Hey everybody, this week and into next week, we're going to take a look at conic sections. Conic sections are formed when you take a plane and you slice it through a cone. So as you can see over in this diagram, I have two cones, one on top of the other. These two cones are joined at the nape, where the two cones kind of come together or meet. That's called the nape, like the nape of your neck. So if you take a plane and you slice it horizontally or parallel to the base, you get a circle. If you take a plane and slice it through a cone at a diagonal, you get an ellipse. If you go from the base through one of the cones, you have a parabola. And if you take and slice like through a base and through both of these conic sections or cones, then you get a hyperbola. So hyperbola is like a collection of parabolas, but it's all about strategically slicing through those cones. So we've already worked with circles, and then today we're just going to kind of compare and contrast circles and ellipses. So here's an ellipse. An ellipse and a circle, have a center, and then there's some sort of a distance relationship around the perimeter. With a circle, we would call that perimeter the circumference. With an ellipse, we just call it kind of the perimeter of the ellipse. So center, and then some ellipses are oriented horizontally. Some are oriented vertically. You'll know the orientation just by looking at the equation of the ellipse, which I'll look at here in a minute. So we have a center point, and then if we are oriented horizontally, then these points that are on the exterior of this ellipse are vertexes, vertex, and a set of vertexes is called vertices. From the center, if you go up and down along this minor axis, it's minor because it's shorter, you have your covertexes, covertex, and then both of those would be called covertices if you were talking about them at the same time. Cool things about ellipses are their focal points, focus and focus. So these focuses are inside the ellipse, and they have a cool relationship. If we were in person, I'd have you draw one using a piece of string and um, thumbtacks. It's a pretty cool activity. But anyway, I don't get to see your lovely faces. I hope you're all doing well, though. I miss you guys. Oh, eccentricity is one last thing I want to talk about before I go away from this picture. The eccentricity, or some teachers call it eccentricity, that's just a measure of how squashy your ellipse is. So anyway, here's another picture of an ellipse that's oriented horizontally. F is a focus and G is a focus. These 2 points F and G are collectively called the foci. The length of the major axis, or the distance from vertex to vertex, is F plus G. If you go from focus or focal point F to point P, any point P on the perimeter of this ellipse, and then from that point, straight back to the other focus, so in our case, G, the distance from F to P plus P to G is going to be equal to the length of the major axis, F plus G. And I mean, you probably don't even believe me, but trust me, I know what I'm talking about. And if I could see you in person, I'd have you prove it to yourself. All right, so let's look at an equation and then some graphing. Over here on the right, I've got a picture of a circle. Over here on the left, notice the left, I've got some equations happening. So this first equation is the equation of the circle. I went to the left 2 and I went up 1, and that gave me my center point. And then the square root of 16 was 4. So you can see that from the center, out 4 in all directions helps me form this circle. All right, up pops a blue ellipse next. So the ellipse and the circle have some similarities. X plus 2, y minus 1 tells me that I'm still shifting my center left 2, up 1. Now this time I have a 25 underneath the x squared, and I have a 4 underneath the y squared. Because 25 is larger than 4, this tells me that the ellipse is going to be oriented horizontally. Now, if I want to think about graphing, I start at my center and then I go to the left and to the right 5 units, left and right 5 units. And that's going to give me my vertexes, my vertices. So I'm still going up 1 and up 1, but notice this -7 right here came from the center, -2, -5, and then -2, +5. Left and then right point. Okay, next up I need to plot my covertices. So from the center, I go up 2 and down 2. Where is the 2, up 2 and down 2 coming from? It's coming from right here. The square root of 4 is 2. All right, then the last thing I want to graph are the foci. So the foci are these points inside the ellipse. They'll be laying on the major axis. To get to the foci, what I do is I go still left 2, and then I'm going to add, and I'm going to subtract some value. That value, the 21, where am I coming up with 21? Well, look at these numbers right here, 25 and 4. 25 minus 4 is 21, and then I take the square root. So this really is coming from the relationship a squared minus b squared is equal to c squared. So anyway, I did -2 plus the square root of 21, comma 1. That gave me that point right there. And then -2 minus the square root of 21, and then up 1. And that gave me my other focal point, or one of the foci right there. All right, I have another graph for us. Hold on a second while I pull it up. All right, here we go. So again, red circle, this time my circle is at a center point of right 3 down 2. Yep, right 3 down 2. Looks like my radius is 5. 1, 2, 3, 4, 5. Yep, square root of 25 is 5. My ellipse is going to be oriented vertically because it's more uppy downy than lefty righty. As I looked at this equation with the same center as the circle, yep, 16 is larger than 4. 16 is underneath the y squared. That's how I know that I need to go, it's going to be oriented more vertically. So I went up 4, down 4, and then I went left 2 and right 2. So I've got my center. I need to go ahead and plot my vertices though. So I said I needed to go right 3, down 2, and then up 4 and down 4. So ta-da, ta-da. Sure enough, that worked great. That's exactly where my vertices need to be. Now, can I plot my co-vertices? I don't think I have that going on, but I do want to plot my foci. I'm not going to show you graphing the co-vertices. They go here and here. Anyway, I want to do foci and then get you started on some homework. All right, so still I need to go right 3 and down 2, but then how much do I go up? How much do I go down? My foci are probably going to be somewhere in here-ish and in here-ish. So remember that this relationship is Pythagorean-ish. A squared minus b squared will give us c squared. Well, a squared is just always your larger number, 16. B squared is always your smaller number, so in our case, 4. 16 minus 4 is 12. I'm going to type in a 12 here. I'm going to type in a 12 here, and there are my foci. Perfect. So I wish I could come up with something where I could plot from the focus to a point on anywhere on this ellipse, and then to the other focus. And then I could prove to you that that distance is going to be equal to the entire length of your major axis, or the distance from vertex to vertex. All right, so that's all I have to say about that. What I need you to do now is go back to the classroom and open up the attached PDF. If you'd like to copy down the notes, you can. Otherwise, just use them for your own reference. And at the bottom, there are 4 problems. Work the problems on your own and then upload your answers, or just type in your answers in the attached document. So it's all spelled out in the classroom. Good luck. Thank you, and I'll see you tomorrow.